Hello everyone, in this video we're going to learn on titration calculation, which is another name for it is called volumetric analysis. So here's our learning objective: to calculate the unknown concentration of a given volume of solution, acid or alkali, by titrated with a known concentration and volume of another solution, alkali or acid. So for example, if you have an acid here, you should titrate against with an alkali. So if you got an alkali, you should titrate against with an acid. Okay, this is a neutralization process. So what is titration? Titration is a technique where a solution of a known concentration is used to determine the concentration of an unknown solution. Typically, the titrant, the known concentration solution, is added from the burette to a known quantity of an analyte from pipette. This one you transfer to your conical flask, which is your unknown concentration of the solution, until the reaction is complete. Why do we need to use titration method? Firstly is to determine the concentration of an acid or alkali. So in titration, we determine the volume of a chemical solution, the reagent, required to react completely with the known volume of another solution. FYI, another name for this titration is also called volumetric analysis. So what is meaning of this? When you do your titration practical, you know what this means. So an indicator is needed in an acid-base reaction because both solutions are colorless. So few drops, around 2 or 3 drops of indicator is added into the solution inside the conical flask. For O level, we usually use metal orange, or this is the scale, the color changes. So for metal orange, your acid color should be red, your base, which is the alkali, is yellow. So the middle color, which is the neutral, at 7 should be orange. Yeah, just remember like your rainbow color. Rainbow is red, orange, yellow. Okay, this is the general view on how titration works. So I don't need to explain this so much. You will know once you do it in the practical lesson. Okay. Oh yes, during your titration, once your color in the flask has turned orange, the first orange color, it means that your reaction is completed. The reaction between the acid and alkali has completed. So under the name for this is endpoint. Endpoint is where your solution inside here is neutral at pH 7. For now, let's try the calculations. So in an experiment, 25 cm³ of sodium hydroxide needed 27.5 cm³ of 1.0 mol per dm³ of sulfuric acid to complete the reaction. Calculate the concentration in mol per dm³ of sodium hydroxide needed. So the first step, I've drawn a diagram here. So this would be like your practical. Your known volume and concentration of sulfuric acid is here. Don't worry, in practical you will be instructed where to put, which solution to put on which place. Okay, so don't worry. So the sulfuric acid is placed inside the burette. So the 25 cm³ of unknown concentration of sodium hydroxide will be placed in the conical flask. Why this is fixed? Because of your pipette. Your pipette is fixed with 25 cm³. Remember this, the pipette bulb? Yes, this one. Sorry for my ugly drawing. I shall erase this. First step, before you start to calculate the concentration of sodium hydroxide, you need to write down the balanced chemical equation for this reaction. So the first thing you have is your sodium hydroxide. Let's write down NaOH with sulfuric acid H2SO4 will give you sodium sulfate Na2SO4 and water. This is your neutralization reaction. So balance the equation. You have to put 2 here and another 2 here. Alright, looks good. Second step, label what you got for the acid and the alkali using table like this. Okay, I've sorted out who is the alkali, who is the acid. So let's separate them into table like this. Okay, first thing, V1, M1, V2, M2. V means volume. This M means your molarity or concentration in mole per dm cube, yeah. Solution 1. Number 2 means solution 2. That's how we categorize them. So let's put their values. This one 25. From your question here, 25 centimeter cube of your sodium hydroxide, just put a number 25.0. M1, your concentration. Alright, this is the unknown, right? So this is the question mark. Next is the acid. Your sulfuric acid, 27.5 centimeter cube. Okay, this will be your V2. M2 is this 1.0 mole per dm cube. Just put the number 1.0. Here you go. Step 3, use this formula. M1V1 over M2V2 is equal to the number of moles of solution 1 from your chemical equation must be balanced, divided with your number of moles of solution 2 from chemical equation. If you're not sure what equation is this is your chemical equation, which is from your step 1. You have to refer this, yeah. Number of moles means the number in front, the coefficient in front of your solution 1 and solution 2. So who's your solution 1 and solution 2? Let's refer back from your previous slide. Solution 1 is your NaOH. Your solution 2 is your sulfuric acid. Let's label here. So what coefficient do we mean? This one. Your number of moles is here in front of it. What could be the number of moles in front of your sulfuric acid? Here you have your imaginary one, invisible one here when you don't see anything. Okay, here. Then substitute the value from step 2 and find the value of your missing M1. To make it easier, I've copied the step 2 table here. So let's write our working. M1 is unknown, so I'm going to leave it as M1. Oh yeah, bear in mind, in between here should be multiplication, yeah? Just like algebra in maths. Here is multiplication. V1 is 25. Divide with M2 is 1 times 27.5 is equal to your number of moles from equation. Solution 1 is your sodium hydroxide. So the number of moles for sodium hydroxide here is 2. So you have to put here 2 over number of moles of solution 2, which is your sulfuric acid, which is 1, yeah, the one highlighted yellow, so I'm gonna put here 1. So next what you need to do is just cross multiply. And do your maths. Alright, after this, move the 25 from the left hand side to the right hand side. You'll become divide. So M1 is equal to 55 divide with 25. Then you should get, by using your calculator, 2.2 mole per dm cube. Bear in mind this is concentration, yeah, your M, this is molarity, so this is the concentration of your sodium hydroxide. Okay, another case here, a student titrated 10 cm cube of aqueous calcium hydroxide with hydrochloric acid. Yes, the chemical equation has been provided. It is required 4 cm cube of 0.01 mole per dm cube of hydrochloric acid to neutralize the 10 cm cube of aqueous calcium hydroxide. Calculate the concentration of calcium hydroxide. So as always, first step, write down the balance equation of this reaction. If provided, skip this step. Okay, is provided, you may skip this step. Alright, second step, label what you got for the acid and alkali and put them to table like this. So sort them out. What is alkali? What is the acid? Your alkali is your CaOH2. Your acid is HCl. As always, please put a line as a barrier. First step, volume, molarity, volume, molarity. First solution, second solution. Okay, label accordingly. Your volume for calcium hydroxide was 10. You can ignore the unit. Molarity is the concentration. You don't have, or let's put the question mark. Let's move on to the acid. Solution 2, volume is 4. So let's put here 4. Molarity for your acid here 0.01 of hydrochloric acid. So I'm just gonna put 0.01 only. You can ignore the 0 at the back. Okay, it should look like this. Third step, use the formula M1V1 over M2V2 is equal to the number of moles of solution 1 from equation over number of moles of solution 2 from equation. To recall back, this is your table from your step 2. And this is your chemical equation from step 1. So I have copy paste here. So let's substitute the values into this formula. M1, you have no idea because here is unknown, right? Unknown M1, so I'm gonna leave it as M1 times V1 is 10 over M2. Your M2 is 0.1. Your M2 is 0.01. Your V2 is 4. Let's put it here. 0.01 times 4 equal to number of moles of solution 1. Your solution 1 is your calcium hydroxide. So the number of moles in the equation here is your invisible 1. So I'm gonna put 1 here. Divide with your number of moles of solution 2 from equation, which is solution 2 is your acid, yeah, here. So here the number of moles is 2. I'm gonna put here 2. Then we do cross multiply. Then you have this. Your 20 from your left hand side should be put to the right hand side, becomes division. Then by using calculator, you should get 0.0002 mole per dm cube. Okay, just a reminder, V means volume, the M here is your molarity or concentration in mole per dm cube. So now we have achieved our answer. This is the concentration for calcium hydroxide. Alright, that's about it. That's the end of our lesson. So make sure you must know from step 1 until step 3, and you must remember this formula by heart. Okay, this formula very useful for your titration experiment. This formula is not only for you to find the concentration of the solution, but you also can find the volume if anything is needed, your V1 or your V2. Well, as long as you know how to manipulate the formula, anything is possible with this formula. Alright, that's about it. That's the end of our lesson. I shall see you on our next lesson. Thank you.